Okay students, today we are going to take a session on class 12 CBSE chemistry, first chapter, that is solutions. And actually the first chapter was intended to be solid states. Now solid state chapter is deleted from our syllabus. We are going detailedly into the solutions chapter. First of all, we are going to discuss what a solution is. A solution is a homogeneous mixture of two or more substances. It means that a solution is just a mix of two or more substances. What are the substances or components of a solution called? The components of a solution are solute, which get dissolved, and solvent, which dissolves a solute. It means that there are two components in a solution, and the first one is the solute, and solute is dissolved in the solvent. This means that there are two components, the two components of solute and solvent. When a solute and solvent combines, we get a solution. Example is air. Air is a gas in gas type of solution. This means that gas is dissolved in gas in the case of air, and air is a mixture of gases. The second one is sugar syrup. It's a solid liquid type of solution. This means that in sugar syrup, sugar is dissolved in a liquid. Sugar, which is a solid, is dissolved in a liquid, or it is dissolved as a liquid. Okay. And the next one is that alloys. Alloys are actually solid type of solutions. Alloys are actually solid type of solutions. Solids are dissolved in solids to form alloys. Okay. Example of an alloy is brass or bronze, etc. Okay. Then we want to look at the importance. They are used in industries, medical applications, daily life. Solutions are having a lot of applications, a lot of uses in our day-to-day life. They are used in industries, medical applications, and in our daily life. Okay. We are first looking into the types of solutions. Solid in solid type of solution. Solid in solid type of solution means that, for example, alloys like bronze, copper, and tin. Sn means tin. Copper and tin are mixed to form an alloy called bronze, something that we use in our daily life. Then solid in liquid type of solution, the example is sugar dissolved in water. Sugar being a solid and water being a liquid, and sugar dissolved in water is a type of solid in liquid type of solution. The next one is a liquid in liquid type of solution. And alcohol dissolved in water is a type of liquid in liquid type of solution. You already know that alcohol is a liquid and water is a liquid, and when alcohol is mixed in water, it's a type of liquid in liquid type of solution. The next type of solution we are dealing with is a gas in liquid type of solution. Gas in liquid type of solution, the example is oxygen dissolved in water. Oxygen being a gas and water being a liquid. So oxygen dissolved in water is an example of a gas in liquid solution. The next one is gas in gas type of solution. Atmospheric air is an example of gas in gas type of solution. It's an easiest example of gas in gas type of solution, which is because atmospheric air is a mixture of a lot of type of gases, and you already know there is oxygen, nitrogen, helium, carbon dioxide, everything inside atmospheric air. All these constituents, most of these constituents are gaseous type of things, and there are also dust particles, and there are other substances are also there. The main thing is that is mainly composed of gaseous components. Gas in gas type of solution, example is atmospheric air. Okay. The next one we are dealing with is solubility and its factors. Solubility means maximum solute dissolved at specific conditions. This means that you take some salt and you dissolve it in water. What happens is that you can dissolve more of salt up to a certain point, and after reaching a maximum point, you cannot dissolve salt in it. You can add salt because you have your hands and you have your spoon or something. Then you can add salt, but it doesn't mean that the salt will be dissolving. There is a maximum amount of salt that can be added to water so that it dissolves. Okay. After this threshold, or after this time, the salt won't be dissolved in water anymore. So solubility is a maximum solute dissolved at specific conditions. This means that if you change the conditions, or if you heat the water more, you can add more salt to it. Okay, that's what it means. Specific conditions means that solubility is a maximum solute dissolved at specific conditions. Okay, we can look at various factors which affect solubility. Okay, the number one factor is that nature of solute and solvent. First factor is the nature of solute and solvent. What do you mean by nature? Nature means that which solute or which solvent take place to form a solution. The first factor is the nature of solute and solvent. Solubility depends on the first factor. It is solute and solvent nature. The next factor for which the solubility depends is on temperature and pressure for gases. Okay, for gases it depends on pressure, and temperature is in general for any type of solution. So in case of gases, the solubility depends on pressure. In case of all the solutions, whether it is a gaseous solution or a solid solution or liquid solution, the nature of solute and solvent, temperature, and everything are the factors which the solubility depends. Okay. The next thing is that a higher temperature increases solubility of solids but decreases the solubility of gases. This means that when the temperature increases, the solids get more dissolved into the solution, but gases will tend not to dissolve in case when the temperature increases. This means that when you add salt to water and you increase the temperature of water, what happens is that more and more salt can be dissolved when the temperature increases. But when you are dissolving a gas to water or some solvent, what happens is that when temperature increases, the solubility of that gas in the solvent decreases. Okay, higher temperature increases solubility of solids but decreases solubility of gases. The next thing is that higher pressure increases gas solubility. When the pressure is higher, the solubility increases. This is as per Henry's law. When the pressure is higher, the solubility increases. For a gas, when the pressure is higher, the solubility increases. This is in accordance with the Henry's law. Okay, we can go detailedly into the Henry's law. The statement is that gas solubility is proportional to pressure above liquid. This means that the solubility of gas is proportional to the pressure of the liquid above the gas. Okay, the statement is that C for gases, the formula is that C is equal to Kh into P. It's actually not Kp, it's Kh into P. This means that the solubility is directly proportional to the pressure. Okay, the applications of Henry's law is found in scuba diving persons, the decompression sickness, carbonated drinks. These two are the applications of Henry's law. In scuba diving persons, what happens is that when they are in top of the water, the pressure level is low, and when they go deeper into the water, what happens is that pressure increases, and when the pressure increases, what happens is that the gases gets more and more dissolved. Gases gets more and more dissolved in his blood, and when he comes out of the scuba diving into the normal land, what happens is that these gases which are dissolved in the person's blood gets liberated or get released when the pressure decreases. The person, when standing above the water, what happens is that he has a very low pressure, so that the gases are less dissolved in his body. When he go deeper into the water, the pressure increases, and so that more type of gases get dissolved into the person's blood. And when he come back to the surface of the water, the pressure again get reduced, and these gases get released in form of bubbles, and this causes bubbles in his blood, and this condition is called decompression sickness. And the other thing is that about carbonated drinks. For carbonated drinks, the bottles are sealed at high pressure, so that the gases get more and more dissolved. So the solubility increases when they are sealed at higher pressure. For a soda drink, they are you can go to a soda factory and you can confirm the thing, or you can watch videos of high pressure sealing of soda or carbonated drinks. They are sealed at high pressure because increased pressure gives a more chance of solubility for those substances. Okay. Then we can go to the last topic of today's class, as expression of concentration. The first thing is that mass percentage. Mass percentage is the mass of solute per divided by mass of solution into 100. Mass percentage of a solute is mass of solute divided by mass of solution into 100. This is also applicable for mass percentage of a solvent. Mass percentage of a solvent is mass of solvent by mass of solution into 100. Okay. Next one is a volume percentage. Volume percentage is volume of solute divided by volume of solution into 100. Generally, it is asked about the solute. When solvent volume percentage, solvent mass percentage is asked, we can just change the numerator of solute by solvent. Okay. Volume percentage of a solvent will be volume of solvent by volume of solution into 100. Volume percentage of solute is volume of solute by volume of solution inside bracket into 100. Next one is molarity. Molarity is moles of solute. We need to find the number of moles of solute dissolved in liter of solution. You want to write the number of moles of solute on top and write the volume of solution in liter at the bottom, and you will get the molarity of the solution or molarity of the solute. The next one is molality. Molality is a number of moles of solute dissolved per kilogram of solvent. You want to write and find out the number of moles of solute, and we want to write it at the numerator, and we divide it by the mass of solvent in kilogram. Then we will get what is called molality. We can do detailed questions about this in coming chapters. The last topic is that mole fraction. Mole fraction is the moles of component divided by total moles. Okay, this is mole fraction means that moles of component. If there are 2 moles of component A, there are 2 components A and B in a solution. A is of 2 moles, is present in 2 moles, and B is present in 3 moles. Then mole fraction of A is 2 by 5. How it happens is that moles of the first component is 2 and total number of moles is 2 plus 3, 5. In that case, we will get the mole fraction of A as 2 by 5. Okay. This is the first part of the chapter solution. We will go into details of the next part in the next class. Meanwhile, if you are interested in personal one-to-one online classes, you can just contact the number described above. If you want to get into the more chapters of this subject or many other subjects in CBSE, chemistry, physics, biology and all subjects, then you can just subscribe to my channel, and if you like the video, just hit the like button. If you don't like the video, just hit the dislike button. You can see in the next video. This is Vishnu signing off. Bye.